Hello, fifth grade. It's Miss Syed. I'm here to give you corrections for pages 200 to 207. I just want to say that you all did a terrific job at completing this assignment and submitting videos and photos of your pages so I could check your work. Remember that as we're going to complete corrections together, you want to have a pen or pencil out to correct your answers. I'm not taking any points off or grading you if you get something wrong. You've all already gotten a complete grade just for completing the assignment. So please make sure you follow along because I'm going to be giving you some important information to further your understanding of plate tectonics. And remember, if for some of the written responses, your answer is a little different from mine, that's totally fine as long as we have the same ideas. So let's begin on page 201 with section 1. This is a true or false section. The first one says, Earth's surface is all one piece. That is false. The Earth is cracked. This entire section is explaining to you that the Earth's lithosphere, the entire crust and that top brittle part of the mantle is cracked, rough, constantly moving, and certainly not one piece. The second one, scientists think the continents once formed a single landmass. That is true. It was called Pangaea, and you're going to watch a video to learn more about that. The sea floor is smooth and level. That is false. When you read in this section about mid-ocean ridges, you learned that there are underwater volcanoes that have been around on Earth, and these are very rough, definitely not smooth, so the seafloor is not all leveled. And finally, all tectonic plates are the same. This is very false, and we'll be doing a few activities, some of them which will be edible to learn more about the tectonic plates and their sizes. Number 2. This was probably the most challenging question, and some of you said that you weren't so sure about your responses. If you'd like more details, please go ahead and read page 206 again. But here is my answer that I suggested for this question. I believe that the cubes will displace more punch than others depending on the size, and that is because large pieces of ice displace more punch than smaller pieces. Just like ice floats on punch, the tectonic plates, which is the lithosphere, float on the ooey gooey asthenosphere. Thick tectonic plates, like the continental crust, will displace more asthenosphere than thin plates, like the oceanic crust. All of this might be a little over your head, especially after the spring break, if you remember from the layers of the Earth unit right before break. You learned all about the inner core, outer core, mantle, and crust. You learned about the asthenosphere and the lithosphere, and that asthenosphere is constantly moving. It's that ooey gooey layer like oobleck and silly putty. Above it lies the lithosphere, which is the Earth's crust and mantle, and it's moving and displacing depending on the size at different amounts. Number 3, divergent. Some of the words that I suggested to describe the word divergent are opposite, different, separate. Many of you had those in your responses. Some of you had different words, but they all seemed quite similar. Convergent, on the other hand, means merge, come together, or meet. Moving on to page 202. In this section, we had to complete number 5. Some of you had reached out to me and emailed me about questions with this one. No worries at all. All you had to do was identify some similarities and differences between the North America and Africa continents, and then South America and Europe. So for this situation, we have South America and Africa having fossil evidence that they were once connected, and those are the Mesosaurus and Glossopteris fossils. They don't have any mountain evidence in South America and Africa. In North America and Europe, we don't have fossil evidence, but we do have evidence that mountains formed approximately 200 and 410 million years ago. Moving on, page 6. Generally speaking, I underlined this section that shows the building of North America from Pangaea. I will tell you, 5th grade, that this section is probably the least important part for science class. I find this information really fascinating, and you will watch a video to learn more about these movements, but please don't get fixated and caught up on the names of these plates. And let me also tell you right now that you don't need to memorize or learn the names of any of the tectonic plates. But of course, you do already know the continents. Moving on to page 204. Number 7, why would many scientists not accept the hypothesis of continental drift? And that is explained right over here in this section, which says that the continents, scientists didn't know how continents moved, and for that reason, they could not accept the theory and hypothesis of continental drift. Over time, we learned more about seafloor spreading and the magnetic properties that exist in the Earth, and that led us to believe the theory of plate tectonics and tectonic plates, which shows that the Earth is moving and cracked. In this section over here, we have number 8. Why is Earth not getting larger if the sea floor is spreading? Here, it explains that older crust is sinking into the asthenosphere as new crust is forming. And number 9, I'm about to show you a demonstration to explain number 9, but the correct answer is that this section over here is the youngest rock, and this section over here is the oldest rock. Here I'm going to show you a really quick model of sea floor spreading. We have the oceanic crust here, the oceanic crust here. Remember that the Earth's lithosphere is cracked. So we have a crack right here in the middle. What happens at these plate boundaries is that they move in different ways. In this case, when we have an oceanic crust and an oceanic crust side by side, they start to have a divergent boundary, which means the two plates pull apart from each other. When they pull apart, we have magma coming out from the asthenosphere. This starts to cool as it comes to the surface. It forms new rock. So this is our younger new rock. And as it keeps spreading out and we have more sea floor spreading, the older rock spreads out further over here. All right, we are back to page 206, where number 11 just asked us to underline the definition of tectonic plates. Really, that's this top section over here, explaining that the entire lithosphere is divided into pieces called tectonic plates. Those plates, boys and girls, are just like jigsaw puzzle pieces. And so the plates move on top of the asthenosphere. They're moving in different directions and at different speeds, and they fit together like a perfect puzzle. Finally, page 207. Number 12 asked you to mark the letter where the Andes Mountains are located on the map, and that is letter B, South America. The Andes Mountains are right here along the west side of South America. Specifically, Chile has a large amount of the South American plate. And what's really interesting is that if you notice here, South America is on this side and the South American plate. The Nazca plate is just to the left of it. And right over here are the Andes Mountains, which is along the line where the two plates meet. So I want you to remember that and think about other places, for example, California, where it's located along a line where two plates meet. That's going to be super important moving forward. And that just about summarizes up to page 207.